All right, here we go. We're going to cover 3-4 and 3-5 today. Starting off on 3-4, solve and graph simple and compound inequalities in one variable and be able to justify each step in the solution. Okay, so when you look at your first problem right here, it's basically solving for n just like we have been. Okay, just be careful of the inequality. If you multiply or divide at the end with a negative, then you're going to have to flip it. Okay, all right, so let's take a look down here and see what we got. We've got 3 times the quantity 5 plus 2n is less than or equal to 7 plus 10n. Okay, I'm going to do the distributive property here first. I'm going to get 15 plus 6n is less than or equal to 7 plus 10n. Okay, like I've told you all along, I like to get my n's together first, and I like to add or subtract them over so that I end up with a positive n in this case. So this is 15 because that cancels out. My inequality stays the same. I get 4n. Just solve for n. Get rid of addition and subtraction first. I get 8 equal to 4n. Divide out the 4. 2. So it's not equal. It's less than or equal to my n. Okay. Notice I'm eating up the n. So now when I look back over here, a, I'm eating up the n. Here I'm eating up the 2. Here I got a negative, so none of those go. Eating up the n. It's just that you can see here the 2 are flip-flop, but the inequality sign goes with it, so we're good. Okay. Problem 2. All right, negative 10 less than or equal to 2x minus 4 is less than 2. This is a compound inequality right here because it's 2 and 1. You're going to solve this problem on the left and this problem on the right. We're going to do them at the same time. When I add my 4, I'm going to add it to both ends as well as the middle, and then the same when I divide out the 2. Okay, so let's see what that's going to look like down here. So I've got negative 10 less than or equal to the 2x minus 4 less than 2. Okay, so I'm going to add the 4. I get rid of addition and subtraction first, just like I always have been. I'm just going to do it all the way across. So I'm getting all of them in one go around. Same thing, undo multiplication by dividing. Do it on both sides. I get negative 3 less than or equal to x less than 3. If that was a negative 2 I divided out, I would flip both inequalities. But for this, I'm good. Now the graph of this, okay, I'm at negative 3, 0, positive 3. Because I've got an equal sign with my inequality, I'm going to get a dot right here. Because there is no equal, I'm going to get a circle right here. And x is greater than this but less than that, so it's everything in between. And when I come back over here, the only thing that matches that is b. And there you can see there's my solid, and there's my open. Okay, my open circle. So, with that in mind, there we go. Moving right along. Again, we're doing this in class 2 as we go. Feel free to write down questions and we'll answer them as you can bring them into class and we'll get them answered. A 3.5. Symbolically represent and solve multi-step and real-world applications that involve linear equations and inequalities. So it's just a step up from what we've been doing already. Okay, some of these problems get kicked up a notch. Problem 1. Mrs. Nelson is buying folding chairs that are on sale for 10 bucks. If she has 50 bucks, which inequality can she use to show that when she buys C chairs, how many can she get? Okay. Well, if C is the number of chairs she wants to buy, and they're $10 a piece, 10C is the cost of those chairs. And she only has $50, so 10C is less than or equal to the $50. So that's right there, it's A. Okay. Here it's saying you could spend more money than the 50. Same thing here. Here it's saying you're less. Well, we have $50, so we can spend up to that. So that's why the equals needs to be added. So it's A. Pretty straightforward. No real work to it. Here, problem 2. George is saving money to buy a bicycle. Currently, he has saved 2/3 of the money he needs to buy the bicycle. He earns $14.50 more because he mows lawns. Now he has 4/5 of the money he needs to buy the bicycle. Determine the cost of the bike. Okay, well, we'll come back down here. Let's clear this out. All right. If C equals the cost of the bike, we know that right now he has 2/3 of that cost. Of means to multiply, and it said it right there, of the cost. We know of means multiplication. Then he just made $14.50 mowing lawns, and it says now he has 4/5 of what he needs for the cost of the bike. Okay, now you can make these decimals if you want. This will be 0.8. This is 0.667 or 0.67. Just don't make it 0.6 because you'll round away from what you want to get. Another way, and we did this a ways back, is you can multiply everything by the common denominator here, which is 15. And if you multiply everything by the 15, you'll cancel out your denominators. Like 15 and 3 cancel. 3 goes into itself once, goes into here 5 times. 5 times 2 is 10C. 15 times 1450 is $217.50. And 5 goes into itself once, goes into 15 3 times. 3 times 4 is 12C. Okay? No more fractions. I'm going to subtract my 10C just like I would have before. So I get $217.50. And that equals 2C. Then just divide out your 2. And we get $108.75. That's the cost of the bike. Okay. Again, you can make these decimals and you're going to get something real close to that. Also remember, when you put the answers back in here, it's 108.75 or it's 108.75. Either start here or end here. Okay. Moving right along. Problem 3. Attendance at the carnival was 425 the first day. The third day was 575. Assuming attendance increases the same each day, how many people are there on the 6th day? Okay. We can kind of look at this in a picture form. What I mean is we can look at it such that the first day was 425. The second day I'm not sure, but the third day was 575. And if it goes up in equal increments, we'll get to here where we find that 6th day. Well, from here to here is 150. Cut that in half. That means we're adding 75 people a day. So this is 500. I'm just going to keep right on with the pattern. 650, 725, 800 people on the 6th day. I just kept adding 75 each time until we got to it. 800, boom, answer C. Okay. Problem 4, the cost of renting a van for one day includes a flat rental fee plus a charge for each mile the van is driven while it is rented. A van that is driven 107 miles costs $97.15. If it's driven 127 miles, it costs $106.15. What's the flat rental fee? Okay, well, let's take a look here. We did a problem like this already, similar to where we can use the similar logic on it. We know that it's going to be that flat fee plus the cost per mile, I'll just call it C, times the number of miles, and that equals your total charge. Okay, well, if I look at the information that's given me, I know that when they went 107 miles, it cost them $97.15. And when they went 127 miles, the cost was $106.15. So the flat fee is the same on both of them. So what I notice here is I went up 20 miles. And that extra 20 miles cost me $9. So if I took the $9 and divided it by the 20 miles, I get a cost of 45 cents per mile was the charge for the mileage here. So if I come back up here and I say, okay, I had a flat fee that I'm looking for. I went 107 miles, and I'll just take the first example. And they're charging me 45 cents per mile. My total charge was $97.15. Multiply this out. 107 times 0.45. $48.15. That equals $97.15. And if you subtract this over, you're going to get F equal to 49 bucks. So there's your flat fee right there. Okay? So we figured out the distance, extra distance, and what the extra cost was. That's strictly mileage because the flat fee was the same in both cases. And I take mileage, or the cost divided by the miles, and I get 45 cents per mile. Plug it back into my base formula. We did a problem just like this right off the bat in the first section. And then just subtract it over, and it's $49 for that flat fee. Boom, D. Okay? All right. That's those two sections there. We'll pick up, let's see, the next thing will be 3.8, I believe. And we'll get on that when we get going in the next section. All right, hopefully that's been helpful to you. If you got any questions, bring them in class.